if you want to determine the x value at Q, okay, it's important for you to know that in this case here, our circle has got what's called a unit radius, which means the radius of the circle has to be 1 unit long. All right? So this one here is going to be our R. So if you put the R equal to 1, say here, to determine the value of x, you are going to find that this angle theta here is going to be equal to beta. So if you do a substitution, you get cos beta is equal to x over 1, which means x will be equal to cosine of beta. That's how we end up getting the x value at Q as being cos beta. You do the same for sine, it will be sine beta. If you substitute r equal to 1 here, where there is theta, you put beta, you get the y value at Q being equal to sine beta. Now we do the same for point P as well, but the angle theta now changes from being beta to now alpha, and alpha is an obtuse angle, right? And our x value will be cos alpha, the y value will be sine alpha. The same concept that is used to get the coordinates for Q is also used for the coordinates for P. Then you need to determine the length of PQ using two methods. The first method is the distance formula. The second method is the cosine. Now, based on the cosine rule, it's also important for you to be aware, before we go any further, that this angle here, this whole angle here, is going to be equal to alpha minus beta. That whole angle. And that angle is actually P or Q. It's going to be equal to alpha minus beta. Remember, alpha is greater than beta. Okay? Therefore, if you want to calculate the angle inside triangle P or Q, which is angle P or Q, it will be alpha minus beta. Okay? So you have to be aware of that. Then, if we use the cosine rule, remember, the general formula for the cosine rule, here we've got triangle ABC. It's a squared equal to b squared plus c squared minus 2bc cosine of a. Okay, that's the general formula if you want to calculate the length of the side which is opposite the angle A. Okay, of course, you can also rewrite this. You want to calculate B and C and so on. Right? So if we use the cosine rule, if this is our angle, okay, which is P or Q, it means the length that you want to calculate, it has to be PQ. So when you write the formula for cosine rule, it will be PQ squared will be equal to OP squared plus OQ plus OQ squared minus 2 times OP times OQ times the cosine of POQ. Because POQ is the angle. Alright? Then you do a substitution. Now it's important for you to know that OP and OQ are equal. Okay? They are both equal to 1 unit. So if you substitute here, where there is OP, put 1, you get 1 squared. Where there is OQ, put 1, you get another 1 squared. Then here you get 2 minus 2 times 1 times cosine of alpha minus beta. Then you simplify, okay? Once you simplify, you get to a point where you have PQ squared is equal to 2 minus 2 cos alpha minus beta. Right? So you stop there. So this becomes like equation 1. Right? Now, we also need to calculate PQ using a second method, which is the distance formula. Right? Now, to use the distance formula, obviously, we use the formula PQ squared is equal to, well, we can use x1 minus x2 squared plus y1 minus y2 all squared. All right? Sorry, come again? Yes. Yes. Then you equate now the right hand side. Yes.
You said that it's alpha minus beta, but with the POQ, it's X is the beta angle. Doesn't
This angle, the angle between the x-axis and OQ is beta. The angle between the x-axis and OP is alpha. So we want the angle from here, from OP to OQ. Obviously, by observation, it will be equal to alpha minus what? Beta. How many of you see that?
So what did you say?
Okay, if you want to calculate P or Q, right? This angle here is beta, that is the angle between OP and the x-axis is beta. Then the angle between the x-axis and OP is what? Alpha. Okay, let me just use a different color here. So this whole angle here, that's alpha. Then the smaller one, this one here, that's beta. So how can you calculate this angle, POQ? Okay, POQ, I'll just indicate it that way. That's POQ. Okay? It is clear that to calculate POQ, you subtract alpha, you subtract beta from alpha. So that your angle POQ is going to be alpha minus beta. Because alpha is greater than what? Beta. And beta is part of alpha. That's why when you do the subtraction, it will be alpha minus beta. Okay? Then, so when you use the distance formula, that's the general formula which you were taught in grade 10. But now, where we have got the x values now, it's your choice. Okay, remember, to use the distance formula, it's your choice. You can choose the coordinates of q as your x1 and y1, or the coordinates of p as your x2 and y2. Right? Let's say if I choose point P as my x1 and y1, I want to calculate PQ. Right? When you say PQ squared, right? Remember, the x1 here is going to be cos alpha. Okay? So you are going to end up having cos alpha minus the x2 is going to be cos beta. So this will be cos beta squared. Okay? Plus y1 is going to be sine alpha. Okay? In this case here, because alpha is the largest of the two angles, it makes more sense to choose the coordinates of P as x1 and y1. Yeah.
you missed the square root. Are we supposed to put the square root or we not?
Okay, there are two cases when it comes to the distance formula. Right? First of all, where does the distance formula come from? Focus, where does it come from? Do you know where it comes from? It comes from theorem of Pythagoras. Now, remember I told you that when you wrote the investigation, pay attention carefully. When you wrote the investigation, if you write PQ squared, okay, it will be x1 minus x2 squared plus y1 minus y2 squared. When this is PQ squared, please, this is PQ squared. If you want to calculate PQ, the formula obviously you take square root on both sides, so you get PQ equal to the square root of x1 minus x2 squared plus y1 minus y2 squared. So you need to know this difference here. Do you see the difference? Right. So be aware of it. So here, what? Okay, because the first formula it's in terms of PQ squared. Can I have your attention? Can I have your attention, please? You see, sorry girls, you too. Can you pay attention, please? No, I'm not talking to you, scholar. Leander and up you. It's like you're not here. Be part of the lesson. All right. Okay. Let me just remind you that the objective of finding PQ squared using two methods is for us to be able to come up with a formula that has got cosine and sine in it. That's the objective. So in the end, the PQ squared must be eliminated. Okay? Also, obviously the OP has been replaced by 1, the OQ has been replaced by 1. So in the end, we need to have a formula that has got trigonometric ratios in terms of alpha and beta. And everything starts from cosine rule distance formula. And please do yourself a favor. Sit down and analyze the difference between these two formulas. The first one, that's the original one, based on the theorem of Pythagoras. Okay? The second one is based on calculating a line segment, PQ. So you take square roots on both sides of the equation and you come up with this. So if I was calculating the distance of PQ, I may not need to write it like this, but I have to write it like that. Because I want to calculate the length of PQ. But in this case, we are not calculating a distance, so it's not necessary to write it this way. It's better to write it that way. Okay? Because this is trigonometry now, and I don't have specific values here to calculate the length of PQ, because I don't know the sizes of angle alpha and angle beta. Yes. Sorry. In which situation? Use the top one, yes, for this situation. Okay, you get the same results, but in the end, you find that if you use this second one here, can I have your attention, please? If you use the second one, right, you are going to get to a point where you have to eliminate the square root. You understand that? If you decide to use this one, you have to get to a point where you have to eliminate the square. And that means you have to square what? Both sides. And then you will come back here. Okay, so it's better to work with the top one. Okay, so when you use that formula, you get to a point where you've got PQ squared equals cos alpha minus cos beta. Then for y1, obviously it will be sine alpha minus sine beta squared. Sine alpha minus sine beta squared. Right? Now, the rest is algebra. Use FOIL. Okay? If you use FOIL, right, you get to cos squared alpha minus 2 cos alpha cos beta plus cos squared beta. Please remember, I shared with you that this gives you what's called a perfect square trinomial. And that perfect square trinomial, it will be cos squared alpha minus 2 cos alpha times cos beta plus cos squared beta. Right? Then this one will also give you a perfect square trinomial, which will be sine squared alpha minus 2 sine alpha sine beta sine squared beta. All right? Then you get to a point where you need to incorporate your knowledge of the identities you did last year. Sine squared theta plus cos squared theta equal to 1. Okay, you have to use that identity. So that this sine squared alpha, okay, and the other one is going to be sine squared beta here. Okay, I'm looking at the wrong place here. So we have got cos squared alpha here, sine squared alpha. We also have sine squared beta and cos squared beta. If you add those, they give you 1. Okay? Then you simplify, that's basic simplification, until you get to a point where you get 2 minus 2 cos alpha times cos beta minus 2 sine alpha sine beta. It's just basic algebra. Okay? It's just basic algebra. Then, when you get to this point here, where I'm putting a tick, this will be like your equation 2. Okay? And this is equation 1. So you have to equate now. Because this is PQ squared, that's also PQ squared. So you equate the right hand side to eliminate PQ squared. When you do that, you end up getting 2 minus 2 cos alpha minus beta is equal to 2 minus 2 cos alpha cos beta minus 2 sine alpha sine beta. Then you need to make cos alpha minus beta the subject. Okay? So you have to make cos alpha minus beta the subject, and you come up with cos alpha times cos beta plus sine alpha times sine beta, which is the main compound angle identity. Right? Now I want you to be aware that this proof, okay, is not examinable. Okay, it's not examinable. But it helps you to understand where the compound angles come from. Okay, it's not examinable, but the use of this identity here is examinable. Okay, so let me move on to the other 3. Now, the other 3 compound angles, okay, just to summarize this. Right, so the main compound angle is cos alpha minus beta is equal to cos alpha times cos beta. If there's a minus there, you put a plus, so that will be sine alpha sine beta. This is the mother of the compound angle identities. Okay, when you write examination, it is provided together with the other 3, which I'm going to derive now. Now, the derivation of the other 3 is examinable. Okay, and it starts from this one here. Right, so the second one, which I'll call number 2, okay, maybe I can call this one number 2. This will be number 1, but it's the mother. Maybe you can call it that way. So this is like the mother. This one here. Okay? I'm going to highlight it that way. So let's derive the other 3. Now, to derive the other 3, we apply our knowledge of trigonometry from grade 11 together with this identity. Okay? So we need to derive cos alpha plus beta. Okay? Now, I'm sure you remember that you did, okay, last year you did what's called reduction formula with negative angles. Now, this cos alpha plus beta, we can write it as cos alpha minus, open bracket, minus beta. And then you put the square bracket. Cos alpha plus beta, okay, can be written as cos alpha, okay, minus, open bracket, minus beta. Where is that coming from? Well, to derive it, we need to use this identity. And obviously, I'm sure you can see that on the left hand of it, we have got this minus here. So the objective would be to convert this plus here to a minus, using the knowledge that you already know, including integers and so on. So to create this minus here, the only way you can do it is to subtract a minus beta, because minus this minus and that minus will give you the plus. Also, because we need to use our knowledge of reduction formula to actually do the proof of the second compound angle identity. Then, but you have any question there? Yes. All right. So from here now, we now use our knowledge of reduction together with this identity. So this becomes cos alpha, which is what I have here. There is a minus here, but the angle is now minus beta, so it will become cos minus beta. Okay? Okay, remember this cos minus beta is the same as cos beta. Right? We simplify it. There is a plus here. Can I have your attention, please? Can I have your attention? There is a plus here, so I need to put my plus. Please take note, I'm not doing anything that you can say, Mr. Shikoda, this is out of the world. I'm using the knowledge of grade 11 trick together with this compound angle identity. Okay? To derive the second compound angle, you need the first one. To derive the first one, you need the cosine rule distance form. Okay? So this becomes sine alpha, okay, times sine minus beta. All right? Now, last year, you did reduction of negative angles. This cos minus beta, cos of minus beta is equal to cosine of positive beta. Okay, from last year. Then sine minus beta is equal to negative sine of beta. That's from last year. Okay? Then this will be equal to, now we end up getting cos alpha times cosine of beta, right? Plus sine alpha times minus sine beta, like that. Okay? But this minus sine beta, because of this plus here, this sign, which is the addition sign, is going to change from being positive to negative because of this minus sine beta. Because positive sine alpha times minus sine beta will give you a negative sine alpha times sine beta. Yes? Sorry? Which part? Right. Do you remember this from grade 11? So I substituted this sine minus beta by minus sine beta. Sorry? You know, some of you, if I look at you now when I'm standing in front of you, you see, your body language is, it's like you didn't want to come to school or what? I don't know. It's the first lesson of the day. All right, listen. Listen. I'm going to re-explain this. But please, be part of the lesson. Be part of the lesson. I said, last year, we were taught that sine minus beta is not minus sine beta. So we need to remove this sine minus beta by replacing it by minus sine beta. That's why I put the minus sine beta in brackets. Can you look and pay attention? Also be aware that there is multiplication between sine alpha and minus sine beta. There is multiplication. Okay? Therefore, if I multiply these two, it's like multiplying x and negative y. You get minus xy. So this positive sign changes from being positive to negative, so that you end up having cosine of alpha times cosine of beta minus sine alpha sine beta. Okay? So that's the second compound angle. Right? And please take note of this. This is very important. There is a plus on the left hand side between alpha and beta, but there is a minus here between the sine ratios and the cosine ratios. Also, for the mother as well, there is a minus here between alpha and beta, but there is a plus here between cos alpha and cos beta and sine alpha and sine beta. That's very important for you to know. Okay? From my experience, some learners, they put a plus here, they also put a plus. It's a very common mistake. Okay? Also, please, don't start getting serious after writing your test. Whilst we are going over now this trick, next time we are going to be tested on this. So this is the time for you to pay attention, concentrate during the course of the lesson. Okay? If you have got any question, you are more than welcome to ask. And I appreciate questions.